teach you how to solve the Norman window problem. And the problem reads as follows. A Norman window has the shape of a rectangle surmounted by a semicircle of a diameter that is equal to the width of the triangle. If the perimeter of the window is 20 feet, what dimensions will admit the most light or maximize the total area? So first we're going to start off by drawing our picture, and I already have that drawn for you. We're going to label the bottom as X and the side for the height as Y. And then for the semicircle, for the radius, in the problem it is told that the diameter is the same as the bottom, so the radius is going to be half of it, so 1/2 x. And the first step we are going to do to solve this problem is find a equation for the perimeter. So to start that off, we are given that the perimeter is 20 feet, but we need to find the equation for it. So we're going to say that perimeter equals x for the bottom length plus 2y for each of the side lengths plus 1/2 times 2 pi r. And we know that the circumference for an entire circle is 2 pi r, but since we only have a semicircle, we're going to multiply that by 1/2. And now that we have that equation done, we are going to set it equal to 20, since in the problem we are given that 20 feet is the perimeter of the semicircle, or the window entirely, I'm sorry. So we're going to have that 20 equals x plus 2y plus 1/2 times 2 pi times 1/2 x. And in the next step, we are going to simplify that equation. So we have that 20 equals x plus 2y plus 1/2 pi x. And now we're going to set that equation equal to 2y. So in that, we're going to have 2y equals 20 minus x minus 1/2 pi times x. And now to get the equation equal to just y, we are going to divide the entire equation by 2, which will leave us with y equals 10 minus 1/2 x minus 1/4 pi x. And that is going to be our final equation for the circumference of the entire window. So now that we have found our equation for the perimeter of our window, we are next going to find an equation for the area of the window. And we're going to start that off by saying the area is x times y, which is going to be your base times your height, plus 1/2 pi r squared. And we know that the area of a full circle is pi r squared, but again, since we only have a semicircle on top, we're going to multiply that area by 1/2, which is going to give us the equation area equals xy plus 1/2 pi r squared. Next, we're going to substitute our radius in for r. So we're going to have that equation as area equals x times y plus 1/2 pi times 1/2 x squared. Now we're going to bring in the squared term, which is going to give us area equals x times y plus 1/8 pi x squared. So now that we have the equation area equals x times y plus 1/8 pi x squared, we are going to substitute in our circumference equation that we solved for earlier into the y spot. This will give us the equation area equals x times 10 minus 1/2 x minus 1/4 pi x plus 1/8 pi x squared. Then we are going to factor in the x, which is going to give us area equals 10x minus 1/2 x squared minus 1/4 pi x squared plus 1/8 pi x squared. Next, we are going to combine our like terms with the negative 1/4 pi x squared and the 1/8 pi x squared, which is going to give us the equation area equals 10x minus 1/2 x squared minus 1/8 pi x squared. And since we're trying to maximize the area of the window, we need to find the highest point of the semicircle. And by doing that, we need to find the vertex of it. But first, we need to pull out an x squared out of the last two terms, which is going to give us the equation 10x plus x squared times negative 1/2 minus 1/8 pi. And the formula for the vertex is going to be negative b over 2a. Our b term is going to be the 10x, and our a term is going to be the inside of the parentheses, so negative 1/2 minus 1/8 pi. And we're going to plug that into the equation, negative b over 2a, which will give us the equation negative 10 divided by 2 times negative 1/2 minus 1/8 pi. And when you plug that equation into the calculator, you will get your final answer of 5.660 feet, which is going to be the maximum area of your Norman window.